Let's make another example for a second order ODE, and let's transform to a two first order ODE and write in matrices format. Okay, so we will use our second order ODE that example, which is the spring mass damping system as our examples. So how we write the higher order ODE for the spring mass damping system? We can write as M x double prime plus Cx prime plus Kx that is equals to Ft, which is the forcing function. Okay. This one is the spring constant. This is the damping coefficient, damper coefficient. And that is the mass of the object. Okay, so this is our spring damping, mass damping system. And how we can convert the second order ODE to first order ODE. So the first step will be convert second order ODE into two first order ODE. And we do the substitution. So lighting x1 equals x and x2 equals x1 prime, which will be x prime. Okay, will be x prime. Then x2 prime will be, so x1 prime equals to x prime, x2 prime will be equals to x double prime, which will be x double prime will be everything in the left, right? So it's negative c divided by m x prime minus k divided by m x minus plus the forcing function. Okay, and you can represent this x prime and x with our substitution function. So that is minus c divided by m, x prime will be x1 prime. Okay, and x prime will be equals to x2 minus k minus 1, x is x1 plus the forcing function. So after we convert this two second order ODE into two first order, so two first order ODE, then we can write into a matrices format, which we can also call it state space representation. Okay, and we can write as d over dt. So that is x1, x2. That is equals to some coefficient x1, x2 plus some coefficient of the forcing function. And when you have x1 prime, that will be equals to x prime, that is equals to x2. Okay, so x1 prime equals to x2, then that will be 0, 1 for the coefficient. For the x2 prime, that will be negative k minus divided by m, that is the coefficient of f1, and then negative c over m, that is the coefficient of x2. The forcing function will be 0, 1 for the forcing function. Just based on how we represent that. And you can write as a state space representation. So x prime equals to a, which is the coefficient, x plus g, which is the forcing function. Okay, so this is examples how we write the second order ODE into a state space representation, which represent by these two first order ODE. Okay.